Hello students, this is Shiva Mitra and again going to tell some more topics of AP and GP. AP and GP. Let me focus once again on all the formulas and concept of the topic. For AP, we have Tn term as A plus n minus 1 into D, and Sn you have n by 2, 2a plus n minus 1 into d, and Sn equals to n by 2, a plus l. Similarly, one more formula we have Sn minus Sn minus 1 equals to Tn. These all four are the formulas for the AP. And if we have to assume three numbers on the AP, then what we will assume? We will assume A minus D, A and A plus D. If you have assumed five numbers for the GP, then you will assume A minus 2D, A minus D, A plus D and A plus 2D. Similarly, if you have to assume four numbers, then you will assume A minus 3D, A minus D, A plus D and A plus 3D. In all the topics we have mentioned, we have kept in mind that the D common difference must remain the same. The common difference must remain same. Once again, Tn equals to A plus n minus 1 into D. For the Tn term, 5th term, 6th term, 15th term, you will have this formula Sn equals to n by 2, 2a plus n minus 1 into D. For some of the terms, Sn equals to n by 2, a plus l, where a is the first term, l is the last term. Sn minus Sn minus 1 equal to Tn. And a minus g, a and a plus g, when you have to assume three numbers of the AP. If you have to assume five numbers of the AP, then you will assume A minus 2D, A minus G, A plus G, A plus 2D. If you have to assume four numbers, then A minus 3D, A minus G, A plus G and A plus 3D. In all the things, we have the same common difference. One more logic we have, that if you have to assume any numbers of the AP, you can have A plus D, A plus 2D, A plus 3D, this is a general term or general sequence of the AP, A plus 4D and so on. So these are the concept of the AP. If I am going to tell you once again, then what it is: Tn equals to A plus n minus 1 into D, Sn equals to n by 2, 2a plus n minus 1 into D, where n means number of terms, D means common difference, A means first term. Wherever you will get n means number of terms. Wherever you will get A means first term. Wherever you will get D means common difference. Here Sn equals to n by 2, a plus l means last term. Sn minus 1 means, suppose you have sum of 5 terms, then subtracting sum of 5 terms minus sum of 4 terms equals to, you will get the Tn term. And similarly, you have to assume three numbers, then A minus D, A and A plus D. If you have to assume five numbers, then A minus 2D, A minus G, A and A plus D, A plus 2D. If you have to assume four numbers, then A minus 3D, A minus G, A plus D, A plus 3D. If you have to, then D is the common difference. And for the general sequence, we have A as the first term, A as the first term, A plus D as second term, A plus 2D third term, A plus 3D fourth term, and A plus 4D fifth term. How you are getting this? This you are getting from the here value. For the first term, you will have n equals to 1. N equals to 1 means 1 minus 1 will be 0. 0 into d will be 0. First term will be a. And for the second term, you will have 2 minus 1. 2 minus 1 will be 1. 2 will that 1d plus a plus d, and so on. So these are the concepts of the AP, which we have seen already. Now we will see some of the concepts of the GP. Now for GP. For GP we have Tn term as a r power n minus 1. For Sn we have a r power n minus 1 upon r minus 1 for r greater than 1, and Sn equals to a 1 minus r power n upon 1 minus r for r less than 1. For S infinitive we have a upon 1 minus r for r less than 1, and S infinitive we have a upon r minus 1 for r greater than 1. Now we'll see Tn terms. A r power n minus 1, where a means first term, r means ratio. Ratio can be taken out as a r equals to b by a, you can say, or you can say r equals to an upon a n minus 1, means second term upon first term, or you can say fifth term by fourth term, seventh term by sixth term. Now Sn equals to a 1 minus Sn equals to a r power n minus 1 upon r minus 1, where r greater than 1. The concept of being r greater than 1, so that the denominator must remain positive. So that the denominator must remain positive. R minus 1. If r will be greater than 1, then this portion will remain positive. And Sn equals to a 1 minus r power n upon 1 minus r for r less than 1. Sn equals to a 1 minus r power n upon 1 minus r for r less than 1. S infinity equals to a upon 1 minus r for r less than 1. Similarly, S infinity means suppose you have a series of GP which goes towards the infinite number of terms. We do not have the number of terms over there, that we have 5 terms or 7 terms or 15 terms or 50 terms. Then we will follow with this formula. For some of that kind of series, we will have S infinity equal to a upon 1 minus r for r less than 1, and we will have S infinity equals to a upon r minus 1 for r greater than 1. Now we will see some more things. Suppose in GP you have to assume 3 numbers, and what you will assume? You will assume a by r, a and ar, or you can have a, ar or ar square. Like this also you can have, like this also you can have. In all the cases you have the r as b by a or an upon an minus 1. The concept of ratio being same between each consecutive terms, that is the concept of the being called GP, so that will remain. Similarly, in the case of arithmetic mean, for the numbers a, b, c are in AP, if a, b, c are in AP, that means 2b equals to a plus c. This is called the arithmetic mean. If 2b equals to a plus c, then that will be called as arithmetic mean. If you have a, b, c in GP, then this means that b square equals to AC, and this is called the geometric mean. If A, B, C are in GP, then B square equal to AC. This is called the geometric mean. Now we will have one more concept out of your syllabus, such as of harmonic progression. Harmonic progression is not in our syllabus. That is not given in the CRT and side book. But if you are referring some standard books, you will get there the concept of HP, harmonic progression. We will not have much detail about harmonic progression. I will just mention one thing, and that will be enough for all the things of harmonic progression. HP equal to 1 upon AP. All the concepts of the AP will be followed in harmonic progression if you are taking the reciprocal of the AP. If you are taking the reciprocal of the AP, that will be called as harmonic progression. Suppose in AP you have A and A plus D. For the common difference, what you used to do, you just used to find A plus D minus A, and you find difference D as the common difference. In case of harmonic progression, you will have the series like 1 upon A, 1 upon A plus D. And now here also for the common difference D, you will do 1 upon A plus D minus 1 upon A, and by solving this you will get the common difference of the harmonic progression. Now this can be written in this form also, A D equals to 1 upon A n plus 1 minus 1 upon A n. D equals to 1 upon A n plus 1. N means, suppose we are having the fifth term, then n plus 1 means sixth term. 1 upon sixth term minus 1 upon fifth term. From the two consecutive differences, we will have the common difference in AP also, and from the two consecutive differences, we will have the common difference of HP also, but that also in reciprocal form. Similarly, all the other formulas of AP, such as Tn term formula, Sn term formula, and rest of the formulas, all are valid for the HP harmonic progression. And but things what you have to remember is that you have to take the reciprocal of all the terms. Now we will see one question. If the arithmetic mean of A and B is A power n plus B power n, if the arithmetic mean of A and B arithmetic mean we are taking A power n plus B power n upon A power n minus 1 plus B power n minus 1. A power n plus B power n upon A power n minus 1 plus B power n minus 1. Then the value of n. You have to find the value of n. It is given to you that A and B are two numbers, and the arithmetic mean of these two numbers is equal to A power n plus B power n upon A power n minus 1 plus B power n minus 1. Then you have to find value of n. What it is given to you according to question, the arithmetic mean of these numbers will be A plus B by 2, and that is equal to A power n plus B power n upon A power n minus 1 plus B power n minus 1 equals to A plus B by 2. Now by taking the cross multiplication, what you will find, you will just multiply this 2 with this term, 2A power n plus 2B power n equals to, and cross multiplying this term with this term, you will get A into both the terms, then A into A power n minus 1 plus A into this term B power n minus 1, and similarly by multiplying with B with both the terms you will get plus, I will write here, B into A power n minus 1 plus B power n minus 1. Now what you will get, 2A power n plus 2B power n, that can be left like this only, 2A power n plus 2B power n equals to, on multiplying A with this term you will get A into A power n minus 1. When the base remains same, power are added, A into A power n minus 1. When the base remains same, power are being added. This means that A power 1 plus n minus 1. Minus 1 plus 1 will be cancelled out, this will become A power n. Now when A multiplied with this term, you will get the same as it is, A into B power n minus 1. And when this B will be multiplied with this term, again you will get the same thing, B A power n minus 1. Now this B multiplying with this term and base remains same, now you will get plus B power n. Now this A power n and this B power n can be taken together with this term, and 2A power n minus A power n plus 2B power n minus B power n equals to, these two terms remain here, AB power n minus 1 plus B A power n minus 1. Now what you will see, 2 minus 1 will be A power n, and similarly here also B power n equals to AB power n minus 1 plus b a power n minus 1. Now what you will see, here it is a power n and here it is a power n minus 1 and here it is a b power n minus 1. What we will do, we will just take this term and this term together and this term together. Now we get a power n minus b a power n minus 1 and this term to that side, you will get a b power n minus 1 minus b power n. On simplifying, what you will get, a power n minus, this can be written as b into a power n upon a power n upon a. Now equals, similarly here also b power n can be taken as common, b power n. Now a b power n upon b and this can be written as minus b power n. Now b power n can be taken common from here and a power n can be taken common from here. You get a power n common, then 1 minus b by a, and similarly here also when b power n is common, b power n taken as common, you will get a by b minus 1. Now I can write here, I think this is visible to you. Now what we get, a power n is outside, a power n, and on simplifying you will get a, on taking the LCM, a minus b by a equals to, here you get b power n as b power n, and in bracket you will get on simplification a minus b by b. On simplifying this term, you will find that a minus b and a minus b both are things that can be simplified, and now you will get this whole term to this side and this term to this side. You will get a power n upon b power n equals to, what you will get here, a minus b upon b into, this a will be top side, a upon a minus b, and this a minus b and this a minus b can be simplified, and this will get a by b, means a power n upon b power n can be written as whole power n, and this here it is a by b. Now what you will see, both the terms have the same base, a by b whole power n, a by b whole power nothing. Now nothing means 1, therefore n equals to 1. On comparison you will write n equals to 1. What you will see, that by taking this term on reciprocally, on comparing, you will get n equals to 1. Once again we will see the question, such as if you have a and b as two terms and you have to take the common difference, you have to take the arithmetic mean of both the terms. What you will do, you will take a and b, a power n and b power n upon a power n minus 1 plus b power n minus 1 equals to a plus b by 2, and on cross multiplication you will find symbol 2 multiplied by both this term and this term multiplied by this terms. Okay, then on simplification a into a power n minus 1, when bases are the same, power are being added, so you will get there a power n, and on simply multiplying a with this term you will get the same result, nothing changes, and when this b multiplied by this term, then also no change, and when this b multiplied by this term, then you will find a change, that the bases are the same, then power gets added. Now a power n and b power n, 1 minute. A power n and this b power n can be taken to this side, and you will find 2a power n minus a power n and 2b power n minus b power n equals to this term, and this term remains to that side without any issue. Now on subtracting, you will find a power n plus b power n like that only, and here you will get a plus b, ab power n minus 1 plus ba power n minus 1 like that only, and then a power n minus b power a power n minus 1 to one side, and this term a b power n minus 1 and b power n to that side. On simplifying, you will find a and is common, and here b and is common, so we will take this and this together and we will find a result that a power n upon b power n, and this term can be simplified and you will get a by b here, a by b, and a by b whole power n equals to a by b, and on comparing you will find n equals to 1. So this is a very good question. Now you can practice some more questions from your side, and rest we will see in the next class. Till that, thank you.